Welcome back. So, patterns. We review a subset of patterns, and I ask you about in your exams. Hopefully by now you have this good level of expertise with the observer, the classical one, the singleton, obviously, and the decorator. Those three are kind of one in each category and probably the most common known patterns there. Other than that, we talk about the builder. I mentioned the fluent builder, a subversion of that. So you know at least those four. Something that I would like to do is to review more, the one in red here. I want you to have at least a knowledge of three in each category. As you notice, we have reviewed just four, and I am planning to review more than that in just a couple of lectures, hopefully one or two. Why? Because my understanding is by now, number one, you have an understanding, a better understanding of the class diagrams. So right now I can show you the class diagram for new patterns if you haven't solved them. And I am sure that it's going to be more easy for you, even if you didn't have experience before with class diagrams, to understand what is happening, that it was for observer or maybe decorator. Your level of expertise now should be higher. The same for the coding. So we can move faster in review these other five than the time that we used to review the other three or four. Hopefully that is true. Moreover, that is going to help to evaluate both your understanding of patterns, but also your understanding of UML class diagrams and relationships. So half because of evaluation and half because I want you to have the knowledge of more patterns. But we're going to review a couple of extras. So extra patterns. Number one, factory. Hopefully when I mention the name, you can, in your mind, project which is the category, which is the problem that we're solving. Is this about the structure? Is this about behavior? Is this about creation? And talking about factories, hopefully immediately you think about, well, a factory is going to create something. Moreover, it's going to be creating something, it's going to be a creational pattern. And this guy is going to be working in the same space or solving the same kind of problem that the builder or the singlet. They are in the same circle, in the same category. Factories, a quick definition of the factory. You know what? The factory is a wrapper for a constructor. A factory is going to be a class. A factory is going to have a method. And that method, this one, this guy, is the method that we're going to call when we want a particular object from a particular type. And this object is what is going to represent the product. And the class that has this particular method is going to represent the factor. Obviously, remember, as in any other pattern, the names should not be or do not need to be the names of the classes. They are the names in the template. We're going to have factories, we're going to have products. The factory is going to provide a method, and that method is going to be the one creating the product. In your source code, what I am telling you is this method here is going to have the new operator. The new of what? The new of the product. And you can be thinking, why? I mean, I can create an object in any place that I want using the operator new. I can use new in all my programs, in any method, in any place, right? In any place in which you want an object, you do equal new name of the class, you have an object. The pattern is telling you, do not put news in every place. Centralize the news and have one and only one place in which you have new for some particular thing, new for some particular object. Every single time that you want an object from a particular class, instead of instantiate the object directly, call this method. Always. Centralization. Help me. Why? Why, instead of having this freedom of doing news wherever I want, why there is this pattern, this solution that is telling me centralize, put one and only one place in which the new could happen? Why that is a good idea or is not? Number one, yeah, you are hiding the constructor. You are wrapping the constructor. Yes. Why that is good? Maybe the concept here is centralized. Why is good to have one and only one place in which something happened? In how many places you can enroll to be a new student? In how many places you can manage your bank account? In how many places you have important information? If you answer one, and why that is good, is because that minimizes the probability of errors. Exactly, validation. When you have one and only one point in which something could happen, that includes you have only one point in which something could fail. If something fails, it's going to fail for everything. But if you need to debug, if you need to review things, there is one and only one point in which you need to do a review. If you are going to refactor, talking about your constructor, there is one and only one point in which you are going to refactor. Talking about connection between classes, if every single place in your code that need a particular object, call this particular point here, this wrapper, any complexity in the constructor, any possible change in the product is in one and only one place. Do we always need this? Not really, but it's a solution for a problem. You are developing a software that is going to create a lot of objects. You are developing a software in which the object creation is very, very important, and it's going to be happening as part of the life cycle of that particular software. If the answer is yes, you need a factory for that object. For instance, for the university system, every single time that a new student enrolls in the university, what we do is to create a new object that represents that student. That object is the one that stores your UID. The university system have a factory of students. And the same happened with Canvas. Every single time that we enroll a new class for a new child, we have a factory. In fact, we have factory for a student. We have factory for courses because it's something that we're going to be doing a lot. You are going to create objects in a big amount, in a big number. It's a good practice to create factories. That's it. This is not static. So something that is going to happen later is you can make a factory static. Well, you can make a factory a singleton if you only want one factory for that particular group of objects. But that is a different story. This one, the factory, is an object, have a constructor, have methods, could have variables. But that factory is the only one that can do the new for the product. You never do a new for the product outside of the factory. At least that is the intention. So could be static or not, could be singleton or not. You can combine patterns. Good. I am going to show you the example, obviously, but the first idea is, what is the problem? What is the solution? What is the problem? I am going to be creating a lot of objects. The solution, create those objects in only one place. So we have the control. That place is going to be called a factory. And therefore, the object that we're going to create is going to be called the product. Now, at this point, something that you will notice is all the patterns usually ask for classes. and interfaces. Having interfaces is a very good practice. This pattern in particular, you're going to notice. We're going to have a class and an interface for the factory. And we're going to have a class and an interface for the product. Why? Because creating an interface for the factory and creating an interface for the product allow you to define several different classes that are factories for several different products or for the same product. It is going to be a common practice for the patterns. You are going to notice in several examples that I'm going to show you today, interfaces and classes. Always an interface that defines the methods that you're going to have without the body, and you can have multiple implementations. Usually one in the example, but the idea is you can always replace the factory just by inheriting from the interface. The same with the product. Exactly. Having these guys and these guys give you the power of polymorphism behavior without depending of classes. But that is something that we need to practice in a project. So thinking about the factory as a pattern, this is the UML diagram. Interfaces, classes, realization, and always one connection from the factory to the product. Which is the connection? The call to the new operator, the call to the constructor of the product, at least, obviously. You can have more, but at least you're going to call the method, the constructor in the product, from the factory. One point to create objects. The class diagram, usually this is the class diagram that you're going to solve in the Gov pattern book. That is the example that the authors provide to us. I just want you to notice they call the abstract factory what we're going to use as an interface. You can have at least one implementation, obviously, and you can have more. For the product, the same idea, the abstract product, you can have at least one implementation or more. It doesn't matter, and there is a connection between the factory and the product that is being created. That connection is a call to the constructor. A call to the constructor is a dependency. We are calling a method, but we are calling a method not for doing an action. We are just calling a method that is not going to do any action. That particular relationship is called dependency. It's not association, the one that we have been used before. It's a particular type of association in which no action is going to happen. Again, we're calling the new, we're calling the constructor. That is the case when you can show this arrow with the dot line, dependency. I do not want to go into the details for that. I'm just explaining this because we are going to notice these lines, a connection, an association, but used for the constructor. I am okay if you follow with this one. It uses a connection calling a method. And that is the look of the factory pattern. Obviously here we have more products, we have more factories, and therefore you're going to notice several connections, all the connections between one factory and the particular product that that factory is doing. One factory can create more than one product. That is possible. There is no limitation for that. One factory, several products, more than one factory, the same product. Any relationship that you need to implement. The coding for this, I think right now is kind of very simple. You can be imagining what is going to happen here with the source code. The source code for this, and we're going to move to Java. The first thing that is going to happen with Java is we're going to use interfaces. We're going to use interfaces as the parent, right? Unless we need something in particular, variables and methods with a particular body from the beginning. The parent, a good idea, interfaces, if they only have a method that is empty. Number two, you're going to notice the names. For the pattern, the names are factory and product, and it's abstract factory, concrete factory, abstract product, concrete product. This is the template. When you go and do an implementation, well, you don't need to use those names. For instance, here, what is going to be my product? In this example, this is product. The product that I am going to create, the problem that I am solving is I am going to create shapes. And shapes, well, that is going to be the parent of everything. And that shape, well, is going to have, rectangles, squares, and so on. These are going to be the kits of this shape. And obviously, what I am going to have is this three classes that are a realization of shape. My square, my rectangle, and this rectangle with the round corners, whatever. You can notice the only thing that we need to do is the parent. In the parent, we define things that are going to be common to this family. In this example, a method draw. Just because I put this one method draw in the parent, that means that all the childs need to implement. If you notice the pattern is not asking us for anything in particular in the product. The product can be whatever you need according with the problem that you are solving. That is the reason because the products are empty. That doesn't mean that they should be empty. That means that the pattern is not asking you to put anything extra. Just put whatever you need. And in this case, in my example with shapes, what I need is a method draw. That is going to print a message, whatever. These are my products. Nothing special here. Factories. Similar idea. I am going to have a factory. I can use whatever name I want. However, something that you are going to notice, and if you have worked with any API in Java, probably you have noticed in something that you have done that suddenly you have a class with whatever name and factory. It is very common to put in the second word or something from a particular class this factory name. And usually when you saw that, it's because that class is a factory. Again, not mandatory, but the people do that. In my example, what I have is this abstract class for the factories. My abstract class is whatever name I want to add. And then that is going to help me to define a method, one or more, that my factories are going to have. In this case, that one. Notice in the pattern, there are methods here. The pattern, the template, is asking us to have in the factories the method that is going to encapsulate the new. Usually, the name for that method is going to be something like getter, get something, get, create, and return, or it's going to be create something. Both things happen with Java, create or get, and they are going to be methods inside of the factory. In this example, I am using get shape in the abstract class, and therefore, in this one, a get, and the commonality is, here is the new, here is the new. For the getters, up to you, you can have parameters. The parameters can help you to configure the product. It is not mandatory, up to the problem that you are solving. With parameters, without parameters, your solution. The only thing is, this is the method, the getter, the create, the method inside of the factory that is going to do a new and is going to return a new. That is the key for the method in the factory. This is a factory. It's creating a product, whatever, using polymorphic behavior and getting you back the product. Another factory with the same method, with a different product. And I can have this and use this factory in a client. Again, this client could be what we call our method main or your class application, whatever. It's the class that is going to use the factory. The class that is going to use the factory, as you can notice, I need a factory. And when I have the factory, I call the getters. There is no new for the product here in the main or in the client, whatever. Instead of the news for the product, what I do is create the factory and call the getters. What is going to happen here, and we're going to review examples of this later, is, well, the new for the factory, what if instead of doing news for the factory, we make the factory a singleton? At the end, is a factory. What are the possibilities that I need more than one factory? If I am happy with one factory, that one can be singleton, and therefore you do not need the new to create the factory. Remember, what do you do when you have a singleton? Name of the class, get the instance, and then call the method getter or create, and you have a new product. But that is going to be an example later. For now, is non-news for the product. Encapsulate the new of the product. That is what you do with factories. What do you need? Interfaces, classes, only one connection between the factory and the product because you are calling the new. That is the representation done. Question for your exam. Can you explain in an open question the difference between builder and factory? Both are creational. What is the difference between having a builder or having a factory? Correct. When you have builders, it's because you need several steps. Exactly. In particular, it's very clear when you review the Fluent Builder. Several calls to several methods, and each call to each method is adding something to the product. And when you are done adding these small things, you can recover the product. You can have the full product. Here is only one call. Here is one call to the constructor directly. Here, you are encapsulating the creation of the product in one call, and usually the idea is you are going to create multiple products. With the builder, the idea is you are going to have multiple calls to the same builder just to create one product. Builder, kind of crafting things, manually doing things. Factory, like manufacturing, like a product line in which with one call you get one thing quickly and you can do another call and get another one, but this one call, one product immediately. Factory, builder, crafting, manufacturing, kind of the ideas. Yeah. Builder, the reason to have the builder, you have a complex constructor. Yes. The reason to have a factory, centralize the creation of the objects. Usually, when you are going to be creating a lot of objects from that class, usually when that class is very relevant for your system, like, again, students and courses in Canvas or the university system, when you have these classes in which you are going to create a lot of objects, and those objects or those classes are kind of the core of the requirements for that system, it's a good idea to encapsulate the creation in a factory. Again, students, courses, Canvas. The core of Canvas is around students and courses. So encapsulate the code, help you to do extensibility or modificability later. That's it, factory. Next one, adapter. adapter, do you remember the category for adapter? It's not creation, right? Behavior or structure? One-on-one. Structure? Okay, I have more votes for structure. You can review the slide. Let's see. What is going to happen with this structure? The adapter, as you can imagine, is very descriptive, the name. I have one class or one part of my system. At the end, this part inside have a particular class that I want to connect with another part of the system. Again, a particular class. You can think about two libraries or two components or two modules, whatever. But at the end, if you go inside, what you have is one class and one class. The connection is going to happen between classes. Moreover, it's going to happen between methods inside of those classes, right? The connection is going to be between methods, but the method lives in classes. So what we're going to connect is one class here from this library, API, component, whatever, with this other. What if we want to connect these two, but they are not compatible? Compatibility. We put something in the middle. Question. What is this compatibility? What is the meaning for, I want to connect this one, and I need an adapter in the middle. The classical example is when you want to plug something and you do not have exactly the same inputs, outputs, and you need an adapter. But thinking about programming, thinking about classes, what is the thing that maybe we will need to adapt between two classes that we want to connect? The main, not the only one, but the main thing. Yeah. Number one, interfaces. Interfaces in particular, what we're talking about this mismatch of interfaces. Well, we want to connect two classes, and what we do to connect the classes, we call methods, right? At the end, maybe we need to create an object, but it's going to be to call a method. The things that we need to adapt, usually, the mismatch of the interfaces, the methods, and if you think about the methods, names of parameters, and if we think about the parameters, the number of the type. We need an adapter. When we want to connect two objects, two classes, and somehow to do the connection, we have an issue with the methods, the method here, and that issue could be, well, the name of the method that I am calling is not the name that I have here. So I need to translate the one that I am calling to the real name, or the number of parameters that I am sending is not the same. So I need to do something with the number of parameters, or the type of the parameters that I am sending is not exactly the same that I have here. So I need to do something here with the number of parameters, and then I can continue with the code. The adapter connect two classes because I have an issue with whatever of this. What we do? Easy. Number one, we're going to have that one is the class that we want to connect with this class. You have a class, and that class you want to connect with the other one. You want to make a connection. But the connection, for instance, is one method in the template, that method is called request. It uses that method in that class, want to connect with another method in the other class. But that connection have issues. What we do, 2 steps. Step number 1, never, never, never you modify the original class. If this class have a particular method with a particular call with a particular thing, you do not modify the original. Because if the original is like it is, it's because some good reason. I mean, unless this is the first version and you're working here, but the assumption is this class belongs to the system, belongs to the API, and for some particular reason exists that request method with that particular instructions, parameters, or names, probably because it's providing a service to a particular part of the system in another place. The first thing that you do, if you need to change something, it's inheritance. I do not modify the original. What I do is I create another class, and that class is going to inherit everything that I have from the original. Everything that I have, moreover, in that new class, I can change the method that I need to update. In this new class, I can do changes, whatever I need, new parameters, new name for the method, new call, new connection, new objects, whatever. Inheritance. Do not modify the original. Create a child, and that child is going to override whatever method you need to change, or methods. Moreover, the reason because you are going to change the method is because you want to make a connection with this guy. And that connection is calling a method in that guy, this connection. So the original problem was to connect this one with this one. You cannot do it for whatever reason. The pattern is telling you, create a child. In the child, do whatever change you want to do. And that child is the one that you can connect with the class that you was planning to have a connection. For the pattern, the new class, the one that you are creating, is called the adapter. And obviously the one with you connect, the adaptee, the original one, the target. So you have these 3 classes in the template. Yeah, that is exactly what you're doing. I mean, you extend the original class and you provide a compatible interface in the subclass. Exactly that we are doing. Yeah, okay. So you can be thinking, I already know that. I mean, that is something that I learned in my 110 class. Never modify the original, do inheritance, and then in the inheritance, in the child, do my modifications. Well, the only thing that I am telling you is that thing that you learn is a pattern. And that pattern have a name, adapter. That is what you are doing, period. Nothing new. There is a name for that. Inside of the source code for request, I mean, what is going to happen here is you're going to have this method request, whatever. And inside of request here, the instruction is going to be called something like that. Obviously, it's going to be more, but that is the idea here. The method request, the one that you are overriding, is the one that is going to call specific request. Just again, the pattern is showing you the template, the general idea. Let me show you an example with this. But yeah, that is what happened. Create a child, in the child, override the method, inside of the method, do whatever you need to do to change the interface and call the method that you have in the other class. Done. Yeah, you are correct. Exactly. Remember, the principle, you're going to notice these object-oriented principles a lot with the patterns, and you should apply them without the patterns either. But polymorphic behavior, that is the reason because we're using interfaces for almost every single pattern. Well, none of them, but several patterns have interfaces. Polymorphic behavior. And this idea of inheritance, instead of changing the original one, you have a name for that. Someone teach you that. Again, the only thing here is those things have a name. And instead of talking about polymorphic behavior, use kind of something too generic. Or instead of talking about particular principle like dependence injection or open close, we narrow the application of those principles to one name that is going to tell you a solution for a particular case. Connecting two classes, adapter, inheritance, call the method, modify one method. You are applying the principles, one name. One name used to be able to communicate with your peers. If I told you, guys, use adapter between these two classes, what I am telling you is all these things that you're understanding is, okay, I am asking you to apply this principle, that principle in one word. That is the power of the patterns. One word that summarizes several things to do. The knowledge that maybe you have or you're learning, whatever. Principles and good practices. That is what the patterns are, a combination of principles and good practices. That's it. Source code, obviously, a typical example. I think that I asked you to do something in your programs like the following. If you remember, I have been asking you to draw squares in the plot, maybe. You remember that you need to draw this square. And probably something that you do not like is the fact that, for instance, I would prefer to tell the computer, maybe in my program, I want to work with this idea of, well, if you're going to ask me to draw a rectangle, what I would like to do is to provide this position and this position, and that is my call to draw a rectangle or draw with X, Y, X, Y. One corner, the other corner. I am sure that you have a lot of software in which that is the criteria for drawing these rectangles. 2 points, and just connect the 2 points and create a rectangle. However, you notice that the interface in Java is kind of different. The interface in Java is 1 point and this distance and this distance, which sometimes is annoying because, well, I would prefer to define this point. When you do the plotting, if you complete this plot in which I ask you to draw these bars that go from the point to the 0 level, it could have been very, very easy to use this one and you define that I am asking you to draw to the 0 level in Y. So have a 0 there could have been very easy. Moreover, the X is the same X that you are moving with a for loop. So X0 could have been easy to draw. However, what you did is to somehow calculate this X and Y here, well, this W and H for every single bar that you draw. I want to think in XY, XY, the library, API in Java, have this X, Y, and 2 sizes. What I can do, instead of doing the calculation of this H and W in every single place in which you are drawing a rectangle, and hopefully you remember your assignment is like, okay, at least 2 or 3 methods drawing rectangles and in which I am calculating this, I can create one class, one adapter. And that class is going to receive as a parameters this, the things that I want to use, XY, XY. And that class is the one that is going to have this equation about, I am going to use X and Y, but I need to calculate these 2 numbers. Instead of the user be concerned about it, instead of you calculating those numbers in your paint component method, I add one class, that one class have these equations, one programmer, and that one is the adapter for being able to use what I want, but translate to what I have, the adapter. Hopefully this one makes sense after the things that you have done. Now, thinking about the source code, hopefully at this moment, you're like, this should be easy. Number one, this is the client. Again, the client is like your class main or your class application or whatever. This class is outside of the pattern. It's just the one that is going to use the pattern. I am going to use the pattern and, well, if I am going to use the pattern, I am going to create an object according with this, an object, the original class that I want to use, and an object, the class that I want to connect. These two, those are the important for me. Okay, whatever. I want this. I want to connect this one with this one. In the middle, I need something. My adapter connected with my adapter. Did you notice the connection is here is the object. This is the object that you're going to be connecting with. The connection is just the parameter. Okay. And then I am going to call an action with my object. At the end, that action is going to be an action here in the adaptee, but that action is going to happen through the adapter. Nothing new. One object, that object, if you notice, is connected with another class. By the way, the adapter is a big picture of the delegate pattern. We have this main component and a delegate. The adapter is the main component. The adaptee is the delegate of the adapter, but different story. I am connecting these two guys and I am asking for one action. Okay. The class, my adapter, I receive this object in the constructor, but I am going to use that object in another method. And what do you do when you have an object that is needed in two methods? You create a variable. That is the reason of the diamond. I send the object, you are going to connect with the object. Later you are going to use the object, but in a different method. I need the global variable. Good. You have your global variable, and just to remember you that this guy is the adaptee, the one that I am going to be using. I put that there. The only role of the constructor is to receive the connection. And then this method is the one that I am calling. That is the method that I am calling in my adapter. That is the method that is receiving the parameters. In my example, the parameters are these x, y, x, y. And what I am going to do is to call the same method in the adaptee. In the pattern, request and a specific request. There is no reason for using two different names. There is no reason for use request or something like that. It's use a template. I am using the same name in both, in the adapter and in the adaptee. Two different classes, nothing happened. My adapter is calling draw. The method in the adaptee is also called draw. For the adaptee, I am sending you x, y, and the sizes, even though I receive here x, y, x, y. The work of the adapter translate. That's it. It's a method. It's a class. The responsibility of the method, translate information to a different information, translate one object to another object, one method to another method, translate. I call the adapter, and what I get is a call to the adaptee. Done. Inheritance, the same shape class that I used before, the same shape that have the method draw. Inheritance, instead of modifying shape, modify the adapter. Done. My product in this case, the adaptee guy, the method draw, the adaptee should not have this name. Adaptee is rectangle, remember? Rectangle, rectangle, rectangle. Obviously here I am just printing a message, but here you remember what I can do here is to use the graphics, draw, rect, and now I can use these parameters, the parameters that draw rect is expecting. I do not need to worry about the transformation inside of the draw method. The transformation happens in a different place. Separation of concerns. Translate the numbers from one format to another in one method, one class. Use those numbers in another method, another class. Separate concerns. Good? Excellent. Another one. I am going to ask you to use these patterns later in a project, so hopefully no questions, everything is clear. And I am moving fast because I think they are easy because you have, as I mentioned before, previous knowledge. So remember, questions now in the moment or emails, but not complaints after the assignment. No question, right? Okay, next one, composite. Do you remember? Can you tell me composite in which categories? So far, I remember I review one, the factory in the creation. We just review the adapter. You told me the structural composite. We are still in a structural, right? Still there. Okay. Structural. This is going to be very, very easy. Hopefully. Composite. This is the class diagram for the composite. Looks familiar? Have you seen this before or something similar? Yes, thank you. There are two patterns. You can review my picture, my slide, and you're going to find structural patterns, and you're going to find decorator and composite. I use a lot of time explaining decorator. This is composite. Can you tell me the difference between those two patterns? You already know decorator, hopefully. And I am showing you the class diagram for composite. So if you remember decorator and you're looking at composite, did you notice any difference? Number one, yeah, here, one thing that is not happening is we do not have childs here for whatever reason. But at the end, having childs or not is not like a reason to be different from the other, right? I mean, yes, in the picture, the childs are missing. Hopefully there is a good reason because the childs are missing. But well, we cannot compare the things that are not here. But did you notice another thing that is missing or maybe extra comparing the two class diagrams? Yeah. Key idea, and thank you for the help. The key difference between decorator and composite is one of them is allowing you to have multiple elements and the other is not. Did you notice these methods here? Add, remove, get. I am sure that you remember those from the observer when we use a data structure and we want to add elements to the data structure, remove elements from the data structure, or do a traversal of the data structure, these three methods suddenly are there. If you compare this one with decorator, you're going to find the similarity of the operation. Both have operation. You're going to find the similarities of one member of the family being used a child and the other member of the family being the child that is also having one element from the parent. These are identical. The difference is here in the template, we have this add, remove, and get. Decorator. If you remember the original one core element, and that one could be connected with a decoration, which could be connected with another decoration, and we can continue. But there is always one original inside of a decoration that could be inside of a decoration, and we continue in that line. If you remember the first example that I showed you was this ball inside of a box, and the box inside of another box, and in another box, and in another box. So, in some point, we review this graphical user interface in Java, and in some point, you help me, what do I need if I want to have more than one ball inside of one box? Or what if I want to have more than one box inside of the next one? And you give me the idea, use remove this one object and put a data structure. Do you remember that one? Instead of having this one, only one to one, just change one to several. Something that I didn't tell you before. When we do that, when we move from one to one to many, when we add the data structure or the array, whatever you want, that change, you are changing also the name of the pattern. Your pattern is composite, one to many. Your pattern is decorator, one to one. So 5 minutes, now you know two patterns, decorators and composite. Makes sense. And obviously what happened with the template is because now we have a data structure, we need methods to handle the data structure, adding, removing, traversal. Clear. Question for your exam, do not forget, one-to-one decorator, one-to-many composite. Question in your exam about which one is what? You can expect that. If you are not convinced about that, composite, decorator, you can compare the two diagrams. And because the data structure. These guys are common, so hopefully don't worry. Also, you will notice no numbers here, no numbers there. If you do not put the number, one, right? A number here, an asterisk there, one too many. If I need to tell you how to identify one pattern from the other, this and this. Well, the thing here, guys, remember, this is all about one word have a lot of meaning. When we talk about decorator or composite, really, when you use one word or the other, what you are telling me is exactly the same structure, but you are telling me if you want this relationship of one-to-one, this line, like I show you with one bowl, decorated, 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 but always in this one line, or you want to be able to have something like more than one bowl in one box and more than one box in another box. If this is your idea, one inside of one, inside of one, inside of one, inside of one, this idea is decorator. If you have this idea, more than one inside of a box with more than one box inside of another one, this idea is composition. So you note that the solution is exactly the same because the diagram is exactly the same with only one difference. The variable that is going to be here is going to be one. On the variable that is going to be there is going to be a data structure like an array of objects or a list. That is really the big difference. And depending on what you want, one variable or the data structure, now you can use the correct name. Decorator, if you want one variable here, or the correct name to use. Now, what I am telling you, if you have a data structure here, is composite. Other than that, the same structure. And you can have also kids here. You can do inheritance, no problem. And you can have kids here in the same way that you can have kids here or more than two kids here. That doesn't make any difference. The difference is the data structure that you put in this class or in this class. One variable or a data structure of variables. One, decoration. Multiple, composition, composite. Other than that, you can notice the similarities. Clear. So composite is equal to decorator with several objects, with several multiple levels of decoration. Yeah, that could be a definition. Good. It's just, instead of explaining to you that I want a decoration with one or with multiple, what the Gang of Four did was, let's change the name. Decoration with one, composition with multiple. That's it. And well, you can take a look here to the example. Add, add. Obviously, we have now remove or display, whatever. But I am pretty sure that you can notice, like, okay, I have this one element and I am adding that element in another one, and then I am adding another one. So these guys here are like the ball that I described before, and these guys here are like the box that I described before. So the original item and the decorations, but now with more than one. That is an example that I already showed you before. The only thing is, now I can tell you, when you have these two here, or this, is composition, decoration with multiple levels. And yes, it's going to look like a tree. Good. Another one. This one, structural, creational, or behavioral? Bridge. No? No idea? Okay. We are still in a structural. So I show you one creational, the factory, then the previous one, structure, and we continue in the structure. It's a bridge. So a bridge is not a creation and probably is not a behavior. A bridge, part of the structure, could make sense. We were talking before about the principles in object-oriented, the coupling. Makes sense. This is a pattern that is going to help me or is going to promote the coupling. Another of the things that we want to have between classes, right? The coupling. You like before, the class diagram. Which part here do you think is the key idea, the one that is the most important in order to accomplish this definition, the coupling? The coupling, one abstraction from the implementation, so they can be independent. Fully agree with that, and hopefully everyone agree. That is the bridge. But that is aggregation. Yeah, that aggregation, that connection there is the bridge between two families of classes. I want you to notice here that basically what we have is a family here. That family have only one kid. It doesn't matter, it's a family. You can add more kids. And what you have here is another family. That family have two kids. Yeah, it could be three or also one. It doesn't matter. There are two families. What the pattern is showing you is we have two families. We have two components, or we have two group of classes inside of the same component. It doesn't matter. Two things. And what we are going to do is connect those two families. And if we are going to connect the two families, we have several different options. Probably the option that a new programmer, a novice programmer is going to follow is, well, I need to connect this guy with this guy. Probably I am going to create a variable, or I am going to call a method. So I am going to have a connection with or without the diamond. Wait, this guy also needs this guy. Probably I am going to make a connection with or without the diamond. Doesn't matter. The pattern is telling you, if you have two families and the kids of this family are going to play with the kids of the other family, instead of making connection among the kids in one direction or in both, just connect the parents. Moreover, if that family has several different levels of parents, just connect the top, the root of both families. And just by doing that, what you have is any member of the family A is going to be able to interact with the family B. And that connection between the root of the two families is what we're going to call the bridge. The white diamond, that is going to tell me that this guy is going to have one of these. And because it's going to have it, it can use it whenever they want. But immediately, all the members of this family have this one. But this one can behave polymorphically. So technically, this guy have this one, or this guy have this one, just because these two can be replaced with the parent. Polymorphism, 100%. Imagine the class diagram. Instead of having this crazy number of connections, aggregations, or use association between a lot of classes here and a lot of classes here, and it's going to be an elegant solution with only one line connecting the top of the parent. And if you think about the class diagram, that is basically about two connections, and these things can be growing like crazy. But the connection is just one single point, a bridge. So something could happen here, something could happen here. The people doing this part don't care about what happened in this part, because in any moment, we can change the bridge to a different component, to a different family that could replace the one that failed. That's it. Okay, guys, I am going to stop here. Next lecture, I start with the source code for this, and we complete our list of patterns. Good? Any question? For the question in the chat, it's going to be aggregation, just because the idea is the methods of the other object are going to be used in several methods. Not only in the constructor. Usually the constructor is going to receive the reference, and what I am going to do is store that one that I receive in the constructor, because other methods are going to use them. So that is the only reason for the diamond. More than one method, including the constructor, is going to use the other object. So in this case, it should be the diamond. Okay, good. Okay, guys, see you next lecture. Thank you.